Okay, YouTube, in my last video we looked at polynomial long division. In this video we're going to look at what's called synthetic division. And basically what we could say is that this is sort of a shortcut method for division, but only of use when we divide by polynomials of the form x minus k. So we say this is a shortcut for dividing polynomials by binomials, and they have to be of the form x minus k. So when you see this example here, it looks like we have this third degree polynomial, and we're dividing it by this first degree polynomial here, but you can see how this is of the form x minus k. Okay, so when we use synthetic division, this shortcut method, synthetic division, basically what we're going to do is this. We are going to make a division bar, except for upside down. And the way this looks is we're going to take our original polynomial here, which is our f of x, and I'm going to rewrite it so that it's got any missing terms filled in. So we have negative x cubed plus 3x squared plus x, and I'm going to say plus 0. So we have to make a note here. Fill in any missing place values. And this is just very true for all division here. We did this with long division, but anything that's missing we have to fill in a 0 for. But basically what we're going to do is we're going to use the coefficients. So those coefficients are what we're going to be, what we're going to put inside of this division bar here. So it looks like our coefficient to begin with, our leading coefficient is -1, then we have 3, then we have 1, and we have 0. So the way synthetic division works is you put your dividend on the inside of here, and then on the outside what we're going to put is this. We're going to write x equals k. Now because this is a note sheet, I'm going to write x equals k, and then underneath this I'm going to write x equals the actual number. But because we're dividing by x minus 2 here, here's the thing. The number that goes out here is the result we get by solving x minus k equals 0. So essentially what I want you to know is this. We are dividing by x minus 2. But if I were to set x minus 2 equal to 0 and solve this, I get x equals 2. So what I'm actually going to put out here is a positive 2, even though this says a negative 2. So if you're dividing by anything of the form x minus k, we could say that if that's a factor, then this must have been the 0 in the first place. And so you always kind of put the opposite out here. But once we get this set up here, basically we would always put a number out here and then our coefficients of our dividend in here. The way this works is we're going to add vertically, write a note here, add vertically, and then multiply diagonally. A. Okay, so here's what we're going to do. The first thing we always do is drop the first term, and we're going to multiply diagonally. So because the 2 and the -1 here are diagonal of each other, I'm going to say 2 times -1. What we're going to do is we're going to take that result, -2, and we're going to put it up over here. And so now here comes the vertical addition. We say 3 plus a -2 is a positive 1. Now we're going to take 2 times 1, and that's going to go up over here. It's 2. So now we'll add vertically. We say 1 plus 2 is 3. So now 2 times 3, that goes up over here. We get 6. And then 0 plus 6 is 6. So the way synthetic division works is just like you saw it there. It's pretty quick once you do a bunch of these. And we're going to put a box around this because what I want to do is I want to label this. This is our remainder. And where we get our quotient here is on the outside of this box. So this right here is actually the quotient. And what we're going to do is we're going to recognize this, that if the last number is our remainder, then this right here is our constant on our quotient. And this here is our x to the first term. And this here is our x to the second term. So what we end up with really is this. We get -1 x squared plus 1 x1 plus 3 constants plus 6 over the thing we were dividing by, which was x minus 2. So to write this a little bit more cleanly, I'd say -x squared plus x plus 3 plus 6 over x minus 2. This would be our quotient right here that we got. And we did get a remainder. So synthetic division is actually a lot quicker way of dividing something if you have a divisor of this form x minus k, which in either of these instances you see x minus k as our divisor form. So I'm going to throw these together really quickly here. I would encourage you to pause the video and try this on your own, but let's go ahead. If you're playing the video, we'll drop in our coefficients of our dividend here, correct. I always have to stop and think about that, dividend. And then our divisor, x minus 2 out here, we'll write actually a 2. And so I don't think this is the same one I just used here. I don't believe so. Nope, we've got everything here. So we'll drop our 1, and we'll multiply diagonally. So we say 2 times 1 is 2. -3 plus 2 is -1. So now we'll multiply diagonally, -2. Add vertically, -9. Multiply diagonally, -18. And then add this vertically, -12. So put a box around this. This is our remainder. So if that's our remainder, then this is our constant, this is our x to the first, this is our x to the second term. So what we get is this, 1x squared minus x minus 9 minus 12 over x minus 2. And you know what? You could write this plus a negative 12 over x minus 2. I just thrown in a negative there. So for this last example, the first thing I notice is that we're missing an x to the second term. So when we fill this in, we just have to be really careful here. We put in a 0 for our x's squared. We say negative 1 for x is the first and negative 7 for our constant. And then out here, because if x plus 3 equals 0, x equals negative 3, we're putting an x value out here. So let's drop our leading coefficient. We say negative 3 times 2 is negative 6. Negative 6 plus 0 is negative 6. Negative 6 times negative 3 is positive 18. 18 times plus negative 1, excuse me, is 17. And then 3 17s would be 51, plus this would be negative. And then we would say adding these together, we get negative 58. So again, our quotient here would be this. 2x squared minus 6x to the first plus 17 constants plus negative 58 over the thing we were dividing by, which the divisor we were dividing by here is x plus 3. So that's how synthetic division works and how it's a lot quicker than long division. So my last note that I want to make here is this. If you have a divisor that is greater than first degree, I noticed that the divisor on this second problem right here is second degree, then it could not be of the form x minus k because it's a first degree thing. So whenever you have a second degree or higher divisor, you have to use long division. If you have a first degree divisor like this, then we can always use synthetic division. Cheers.